Hello everyone. Hello everyone. Welcome to the 10th NPTEL live session of Advanced Foundation Engineering course. My name is sinjandebnath, and today I'm going to discuss about I'm going to discuss about well foundations, and I'm going to repeat some problems related to pile foundations. Okay. So mm, welcome to this session. So let's get started. I hope you can see my screen. Please let me know if my screen is visible to you or not. I hope my screen is visible to you. So my name is sinjandebnath. I am a PhD student in the Department of Civil Engineering at IIT Kharagpur. So let's proceed to the first question. So let's see what is our first question. A circular well of external diameter 8 meter. So a circular well of external diameter of 8 meter and 1 meter staining thickness is embedded up to a depth of 20 meters. Okay, below the scour level. So the circular well having diameter 8 meter and staining 1 meter thickness is embedded up to a depth of 20 meter below the scour level. The friction angle of the sandy soil is 38 degrees. This is 5. 5 is 38 degrees. And the submerged unit weight of the soil is 10 kilonewton per meter cube. Okay, the well is subjected to a horizontal force at the scour level. So the well is subjected to a horizontal force at the scour level. Determine the allowable horizontal force based on Terzaghi's analysis. So in this particular question, we have been asked to determine the allowable horizontal force using Terzaghi's analysis. Okay, so we have also been asked to assume this particular well to be a heavy well. uh, as we know, in case of heavy well, the point of rotation is at the base. Okay, and the factor of safety can be taken as 2.5. Okay, so now let's solve this problem. Okay, so let me first draw this problem. Suppose this is your well. Okay, and this is the scour level, and what is the depth, embedded depth below the scour level? It's 20 meter. So this one is 20 meter. The value of d, the depth, is 20 meter. Okay, and okay, and what else? And let me write down all the data over here. So diameter is 8 meter, staining thickness is 1 meter. Okay, so the dia is around 8 meter. This is the dia. And yes, the submerged unit of soil. The submerged unit weight of soil is 10 kilonewton per meter cube. And phi is how much? Phi is 38 degrees. So factor of safety is 2.5. So we have been asked to determine the allowable horizontal force. Okay. And the well is subjected to a horizontal force at the scour level. That means over here. That is at the scour level. Okay. Suppose that is Q. Okay. And okay. So for heavy well, Q max H plus D is equal to half into submerged unit weight into diameter Kp minus Ka, coefficient of earth pressures, passive and active, D into D by 3. Now H is equal to 0. Why? Because horizontal force is acting at the skull level. Force is acting at the skull level. Therefore, if we put H is equal to 0 over here, so Q max is equal to half into gamma dash Kp minus Ka into d square by 3. Okay, so what we have done is that we have just put this into over here into this equation, and after that we have written this equation. Okay, so now what is Ka? Active earth pressure coefficient, it is 1 minus sine phi by 1 plus sine phi. And one thing I must say that please refer to the lectures. Okay, please refer to the lectures of advanced foundation engineering course to understand this problem better. Okay, because in the lectures the theory has been very well explained. Okay, so please refer to the lectures for the theory part. So now let me get back to the problem. So K is equal to 1 minus sine phi divided by 1 plus sine phi. And what is the phi in the particular question? It is 38 degrees. So 1 minus sine 38 degrees by 1 plus sine 38. Okay. So now if we solve this, we will get the value of k. After solving this, k, the value of k comes out to be 0.24. Okay. Now what is Kp? Kp is just the inverse of 1 Ka. So Kp is just the inverse of Ka, and 1 by 0.24, and it comes out to be 4.2. Okay, so now we have everything to find out the value of Q max. We know sigma dash, that is the submerged unit of soil. We know Kp, we know Ka, we know D, that is the diameter of the well. We have everything. Okay, so now let me just put all the parameters, the value of all the parameters into this equation. So Q max. So let me write down the equation once again. So Q max is equal to half into gamma dash into Kp minus Ka into d square by 3. Half into gamma dash Kp minus Ka into d square by 3. Okay. So now let me just put all the values of all the parameters into this equation. So half into gamma dash, how much is gamma dash? Gamma dash is 10. That is the submerged unit weight is 10 kilonewton per meter cube. So it is 10. How much is Kp? Kp is how much? Kp is around 4.2. And how much is Ka? Ka is 0.24. And how much is the value of d square? That is the diameter of the well. It is around 8 meter. So 8 square by 3. Now if you solve this, you will get the value of Q max to be around 2640 kilonewton per meter. Okay. Now what is the value of capital Q max? It is 2640 into diameter. That is 8. And if you calculate this, Q max comes out to be 21120 kilonewton. Okay, and we have been asked to find out the allowable horizontal force. Okay, based on Tarzagan analysis, and factor of safety is around 2.5. Okay, so Q allowable is equal to Q max divided by factor of safety. Okay, so what is Q max? Q max has come out to be 21120 kilonewton. So 21120 kilonewton, and factor of safety it is given in the question, it is 2.5. So now if you solve this, you will get the value of KQA, which comes out to be 8448 kilonewton. So this is the allowable horizontal load. Okay. So I hope you have followed this problem. Please go through this problem for 5 minutes. After that, I will proceed to the next problem. Okay. Please go through this problem for 5 minutes. And if you have any doubts, you can tell me now, or else you can also post your doubts in the forum of NPTEL, and also you can personally mail me. You know my mail address. It is available in the description box of my YouTube channel. You can mail me over there, and also all the videos of to the of today's session and all the previous sessions are available on YouTube. And to today's video will also be made available later on, so you can refer them anytime. Please let me know if you have any doubt in this particular question. Please go through this question for 5 minutes. So I hope you have all understood this particular problem. So now let me just move to the second problem. So, so now let me move to the second problem. So second problem is based on question number one. So in question number one, if the whale is subjected to a horizontal force of 8,000 kilonewton at the scour level, then determine the moment at the base of the whale due to the unbalanced horizontal force. Use Target analysis. So this particular question, question number two, is based upon the first question. So here uh, we have been asked to determine the moment at the base of the whale due to the unbalanced horizontal force. Okay, and here the oil is subjected to a horizontal force of 8,000 kilonewton. Okay, so in the previous problem, what we did is that in the previous problem, that is in question number one, we have determined the allowable horizontal force. Okay, so here it is 8448. So this is the maximum allowable horizontal load. Okay, this is the allowable horizontal load based on the Target's analysis. Okay, so and in this particular question, I have been this particular question, it is subjected to horizontal force of 8,000 kilonewton. Okay, so moment at the base due to the unbalanced horizontal force. So moment at the base of the well due to the unbalanced horizontal force due to unbalanced horizontal force. Okay, we denote it using MB. Okay, so it is equal to Q allowable minus Q, that is the current load that is acting, which is 8,000 kilonewton, into D, that is the depth of the soil. The sorry, depth of the embedded depth of the well. In the first question, see, it is embedded up to a depth of 20 meter below the scour level. Okay, so D is around 20 meter. So now what is QA? QA we have already found out. QA is 8448. We have determined that in the previous question. So QA is 8448 minus Q, that is the current horizontal load, which is 8,000 kilonewton. Okay, and D is the depth below the scour level, which is 20 meter. If you calculate this, you will get the value of moment, which comes out to be 8960 kilonewton meter. Okay, so this is the answer of this particular question. Go through this for 2 minutes. After that, I will resume. Please let me know if you have any doubt in this particular question. So I hope you have all understood this particular question. So now let me move to the third question of today's session. So this is the third question, which is also based upon question number one. So let me read out the third question. So in question number one, if the well is subjected to a horizontal force of 8,000 kilonewton at the scour level and total net vertical force at the base of the well is 10,000 kilonewton. Okay, after taking care of the buoyancy and after taking the case of buoyancy and spin friction. Okay, so now we have been asked to determine the maximum vertical stress acting on the base of the well. Okay, so we have been asked to determine the maximum vertical stress acting on the base of the well. So horizontal load of 8,000 kilonewton is acting at the scour level, and the total net vertical force is acting at the base of the well, which is 10,000 kilonewton. Okay, and all the rest of other information is same to that of the first question. Okay, so you have been asked to determine the maximum vertical stress acting on the base of the well. So maximum vertical stress. Okay, so Q max. Q max is equal to W by A plus MV by Z. Okay, so what is A? A is the cross sectional area of the well, and what is the diameter of the well? In the first question, it is mentioned over here that a circular well of external diameter of 8 meter. Okay, so the diameter of the well is 8 meter. So d0, the outer diameter, you can say it is 8 meter. So what is the cross sectional area of the well? So it is pi by 4 into d0 square. If you calculate this, you will get so d0 at 8 meter. So if you calculate this, you will get the value of A to be 50.3 meter square. Okay, and what is ZB? It is the polar moment of inertia, which is how much? It is pi by 32 into d0 cube. Okay, so now do, that is the outer diameter of the well. So now if you put the value of 8 meter over here, and if you calculate this, you will get the value of ZB. So ZB comes out to be 50.3 meter cube. Okay, so this one is 50.3 meter square and this one is 50.3 meter cube. So now we need to put all the values of all the parameters into this equation. We know the value of W, that is the net vertical force acting at the base of the well, which is this. We know the value of A, that is the cross-sectional area of the well. We know the value of MB, that is the moment at the base of the well due to unbalanced horizontal force. So horizontal force is 8,000, and we have already determined that in the previous question. Allowable load is 8448, and uh, allowable load is 8448, and the current horizontal load that is acting, which it is 8,000. So qa minus q into d, that is the depth below the scour depth, embedded depth of the pile below the scour depth, which is 20. If you calculate this, you will get the value of moment, which is 8960 kilonewton meter. So now we need to put this. So now we need to put this into this equation. Okay, so what is W? That is, so let me write it over here. So Q max is equal to W by A plus MV by ZB. So W, that is the vertical load. How much is the vertical load? It is 10,000 kilonewton net vertical force. 10,000 kilonewton divided by area. How much is the cross-sectional area? It is 50.3. So 50.3 plus MB. What is the MB? The moment at the base of the wall due to unbalanced force, it is 8960. So it is 8960. And what is ZB? That is the polar moment of inertia. It is 50.3. Now if you calculate this, Q max comes out to be, if you calculate this, this one becomes 199 plus 178. Now Q max comes out to be 377 kilonewton per meter square. Okay, so this is the, so 377 kilonewton per meter square. So this is the maximum vertical stress acting on the base of the well due to horizontal force of 8,000 kilonewton and vertical force of 10,000 kilonewton. Okay, so this is the answer. If you have any doubts, you can tell me now or you can post it in the forum. Please go through this problem for 5 minutes. Okay, so let me proceed. I hope you have all understood this particular problem. If you have any doubt regarding any problems, you can either mail me or you can post the doubts in the forum. Okay, and all the videos of the previous session, and also the recorded video of today's session will also be made available on YouTube, and the link is given on the NPTEL website. You can find it over there. You can refer to these videos anytime. Okay, so let me proceed to the next question. So this is the next question. A drill shaft with bale is provided in the expansive soil. Okay, a drill shaft with bale is provided in the expansive soil. The dead load and live load is 600 kilonewton and 400 kilonewton respectively. The diameter of the bale and shaft is 2 meter and 1 meter respectively. The underlying cohesion of the soil near the base is 150 kPa. The amount of uplift force due to swelling is 1375 kilonewton. Determine the factor of safety under uplift, and the NC bearing capacity factor is 6.14. Okay, so this is a different type of problem. So here, so let me read out this problem once again. So here in this question, there is a drill shaft. A drill shaft with bale is provided in the expansive soil. The dead load and live load is 600 kilonewton and 400 respectively. So dead load DL is how much? It is 600 kilonewton and live load is 400 kilonewton. Okay. The diameter of the bale and shaft is 2 meter and 1 meter respectively. So diameter of bale is how much? It is 2 meter, and diameter of shaft is how much? It is 1 meter. Underlying cohesion of the soil near the base is 150. It is 150 kPa. And the amount of uplift force due to swelling is 1375. Okay. So uplift force is how much? Fu is 1375 kilometer. Okay. And okay. So I'm just saying of kilonewton. And NC is 6.1. Okay. So we have been asked to determine the factor of safety under uplift. So factor of safety under uplift. Factor of safety under uplift. So it is given by CUNC into the area. Okay, cross sectional area. AF divided by U minus FU minus dead load. So let me write it like this: CUNC into AS means how much? It is pi by 4 into dV square minus dA square. That is the diameter of a bale and diameter of shaft. Okay, and what is FU? That is the horizontal. That is the amount of uplift force due to swelling. It is 1375. So FU minus dL. So now let me just put the values of all the parameters into this particular equation. So Cu and C. Let me write it down that this particular equation over here once again. So let me just copy this. So it is this Cu and C. So what is the value of Cu? It is 150 kilonewton per meter square. And what is Nc? How much is Nc? The bearing capacity factor, it is 6.14. And pi by 4 into dV square, how much is the dB? It is 2 meter. It is 2 meter, and shaft is 1 meter. So 2 square minus 1 square divided by Fu. Fu is the uplift force. It how much it is? It is 1375 and dead load is 600. So 1375 minus 600. Now if you calculate this, the factor of safety comes out to be around 2.8. Okay, so this is the factor of safety against uplift. Please go through this problem for 2-3 minutes, and if you have any doubt, you can tell me. Let's go through the problems for a couple of minutes. Okay, so let me proceed to the next problem. So let me proceed to the fifth problem. So, so what is the problem? So the problem is a pile of diameter 0.5 meter and length 20 meter is installed in clay soil. The underlying cohesion value of the soil is 100 kPa. The adhesion factor is 0.4. Determine the gross uplift capacity of the pile. The unit weight of the concrete and soil is 24 kilonewton per meter cube and 20 kilonewton per meter cube respectively. So first of all, let me write down all the information that are given in this particular question. So till now we have all, so up to question number 4 we have discussed about well foundations, and here are some questions related to pile foundations. So let me write down the data. So pile diameter, what is the diameter? It is 0.5 meter. Length is around 20 meter, and it is installed in a clay soil deposit. The 100 cohesion value of soil is 100 kPa. The adhesion factor is 0.4. Determine the gross uplift capacity of the pile. The unit weight of concrete is 24 kilonewton per meter cube, and unit weight of soil is 20 kilonewton per meter cube. So first of all, before proceeding to this particular problem, let me just brief you about the uplift capacity. What it is actually is. So uplift. So uplift capacity of piles. Generally, what happens is that suppose you have a transmission tower like this. Suppose you have a transmission tower and it is being supported on pile foundation. Suppose this is the pile foundation. This is the ground surface, and it is a pile cap over here. Here it is a pile cap, and below the pile cap there are piles. The piles are connected to the pile cap. Okay. So now generally what happens is that so suppose high winds are flowing, wind load is very high in this case, and this will try to rotate this transmission tower like this, right? So due to which what will happen is that this pile will tend to move upwards. Okay. So this transmission tower will try to rotate into this in this direction, due to which the pile tends to get uplifted. Okay. So that's all. uh, and so uplift capacity. So gross uplift capacity, that is the PUG. This is the gross uplift capacity, and it is equal to PUN, that is the net uplift capacity, plus W, that is the weight of the pile. Okay, so you see the weight also contribute to the uplift capacity of the pile, because weight will because weight tends to the direction of weight, that is the weight of the pile is downwards, right? And it will try to restrict the uplift motion. Okay. The weight of the pile will try to restrict the uplift motion, so that's why it also contribute to the gross uplift capacity. Okay. So this is the gross uplift capacity, which is equal to PUN, that is the net uplift capacity, and W is the weight of the pile. So for clay, PUN is equal to alpha dash CUP into A. What is alpha? Alpha is the, that factor. What is that? Addition factor. And what is Cu? It is the underlying cohesion. P is the perimeter, and L is the length. Okay. And one thing I must mention, that is the addition factor. This alpha dash, the alpha dash is equal to, for clay only, it is equal to 0.9 minus 0.00625 Cu, that is 100 cohesion, and this is applicable for cast in situ pile, and Cu, and when Cu is less than or equal to 80 kPa. Okay, and there is another equation, and there is another value of alpha dash which is zero point 0.4, and this one is for cast in situ pile, and in this case Cu is greater than 80 kPa. Okay, and another thing is that if it is a pipe pile, okay, uh, and another thing is that if it is a pipe pile, if the pile is a pipe pile, then in that case alpha dash is equal to 0.715 minus 0.0191 Cu. Okay, and this is applicable when Cu is less than equal to 27 kPa. If the Cu is less than 27 kPa, then we will use this equation. And another value of alpha dash is equal to zero point 0.2, and we will use this when Cu is greater than 27 kPa. Okay, so now let me get back to the problem. So this is the problem. So we need to find out the gross uplift capacity of the pile. Okay, so and in this particular question the soil is clay soil. So here we have written for clay soil, the equation is this: PUN, that is the net uplift capacity, that is this part. It is alpha dash CUPL. Okay, that is CU means 100 cohesion, P means perimeter of the pile, and L is the length. So PUN is equal to alpha dash CU P into L. Alpha dash is how much? Alpha dash, it is already given in the question. It is for zero point 0.4, the addition factor. If it was not given in the question, then we would have to determine that alpha value from these equations. Okay, so P dash n, so PUN equal to alpha dash Cu into PL. So alpha dash is equal to zero point 0.4, and the value of Cu, what is the value of 100 cohesion? It is 100 kPa. So it is 100, and perimeter, that is the 2 pi r, that is the cross sectional, that is the perimeter of the, you know, the pile, which is 2 pi r or pi d. So how much is the diameter? The diameter of the pile is 0.5. So pi into 0.5. And what is the length of the pile? The length of the pile is 20 meter. Okay, 20 meter. Now, if you calculate this, you will get the value of PUN to be 1257 kilonewton. Okay. Now, what is the weight of the pile? The weight of the pile is we need to multiply the unit weight of concrete with the weight its volume, with the volume of the pile. So unit weight of concrete is how much? It is 24 kilonewton per meter cube. So unit weight of concrete into volume of the pile. Okay, so unit weight of concrete is 24 kilonewton per meter cube, and what is the volume of the pile? So volume of the pile is area of the pile into length of the pile. So what is the area of the pile? Pi by 4 into d square. Okay, that is pi by 4 into diameter of the pile. So 24 into pi by 4 into d square into how much? What is the diameter of the pile? Diameter of the pile is 0.5 meter. So so pi by 4 into zero point 0.5 square, that is pi by 4 into d square into length of the pile. What is the length of the pile? Length of the pile is 20 meter. Okay, so into 20. This one is d, this one is d, and this one is l. Okay, now if you calculate this, you will get the value of W to be 94 kilonewton. Okay, so now you just need to sum both these values in order to get the gross uplift capacity. So, gross uplift capacity, it is around PUN plus W. So PUN plus W. So PUN is how much? It is 1257 kilonewton. And what is the value of W? W is this 994 kilonewton. Now, if you solve this, if you calculate this, you will get the value of QUG, that is the gross uplift capacity, to be around 1351 kilonewton. So this is the answer of this particular question. Here in this question, we are asked to determine the gross uplift capacity of the pile. So here is the answer. Please let me know if you have any doubt in this particular question. Please go through this problem for a couple of minutes. Please let me know if you have any doubt in this particular question. Please go through the problem for a couple of minutes. After that, I will proceed to the next question. Okay, so I hope you have understood this particular problem. If you have any doubt, you can tell me now. You can also post your doubt in the NPTEL forum, and you can also mail me personally. You can find my email in the description box of the YouTube videos. All the recordings of all the previous session, including this one, uh, today's session will be made available later on, but all the recorded sessions, all the recorded versions of the previous sessions are available on YouTube, and the link is given in the NPTEL website. You can also refer to them. So let me proceed to the next question. So here is the question. So determine the lateral deformation at the top, that is Z is equal to 0, of a solid free-headed pile subjected to horizontal load of 165 kilonewton. Okay, at the top of the pile. So we have been asked to determine the lateral deformation at the top of a solid free-headed pile. Okay, subjected to a horizontal load of 165 kilonewton. So what is the horizontal load? It is 165 kilonewton, and it is a free-headed pile. And use meet Rees and Matlock approach. So we have been asked to use Rees and Matlock approach. The diameter of and length of the pile. So diameter is 0.5 meter. The diameter length of the pile and length is 20 meter respectively. KH, that is the horizontal subgrade modulus, it varies linearly with depth. In Rees and Matlock approach, KH varies linearly with depth. And EPIP, that is the flexural rigidity of the pile. EP is the elasticity modulus of the pile, and IP is the moment of inertia. And EI means the flexural rigidity of the pile. Okay, so EPIP is how much? It is 45,000 kilonewton meter square. And NH is the modulus of subgrade reaction. So it is 1250 kilonewton per meter square per meter. Okay, so AY and BI are the coefficients. We can also determine these coefficients using the chart. You can find the chart in the video lectures. So AY and BY at Z equal to 0, that means at the top Z by T is equal to 0, which and it is 2.435 and 1.023 respectively. So we have everything. So we have been asked to determine the lateral deformation. Okay, lateral deformation at the top. So let me just now solve this problem. So first of all, I need to find the relative stiffness factor T. So this is the relative stiffness factor, which is equal to 5 to the power of EPIP by NH. This NH is the subgrade reaction modulus. Okay. So now if you just put all the values of all the parameters into this particular equation, we know EPIP, which is 45,000, and NH is equal to 1250. Okay. So now root 5 45,000 divided by NH is how much? It is 1250. So 1250. Now if you calculate this, you will get the value of T. That is the relative stiffness factor. It is 2.05 meter. Okay. Now we need to make sure that it is a long pile. Okay. So we need to find out the value of L by T. L by T is how much? The length of the pile is 20 meter. It is 20 meter. T is how much? It is 2.05. If you calculate this, you will get the value of L by T, which is around 9.8. Okay, and it is obviously greater than 4 or 5, so that means it is a long pile. And for free-headed pile, since we have been asked to determine the lateral deformation at the top, that is at z equal to 0. First of all, let me write down the equation. Y, it is ht cube divided by EPIP AY. Okay, AY at z is equal to 0, that is at the top. So we know the value of H, that is the horizontal load, it is how much? It is 165 kilonewton. And T is how much? T is 2.05 cube. EPIP is how much? 48,000. And how much is AY? The coefficient. Coefficient is around 2.435. Now, if you calculate this, you will get the value of lateral deformation, which is 77 millimeter. Okay, so lateral deformation of the free-headed pile, it is 77 millimeter. Please go through this problem for a couple of minutes. After that, I will proceed to the next problem. And if you have any doubt, you can let me know. Okay, so I hope you have understood this particular problem. So let me proceed to the next one. So So as per IS 3955/1967, what is the grip length or depth of well foundation below the maximum covered depth? Okay. If the maximum covered depth or the deepest cover below the high flood level is 24 meters. See, let me read out this question once again. As per IS 3955/1967, what is the grip length or depth of well foundation below the maximum covered depth if the maximum covered depth or deepest cover below the high flood level is 24 meters? So it is like this. Suppose this is your well and this is the high flood level. Okay, it's the high flood level and this is the covered depth. Okay, so this particular distance is around 24 meters. Okay, that is the maximum covered depth. It is 24 meters, and we have been asked to find out the grip length. So that means this portion which is embedded below the maximum covered depth. Okay, it is embedded, this portion is embedded below the covered depth. So how much it is? So according to IS code IS 3955, the grip length should be the the grip length should be greater than one third the maximum covered depth. Okay, one third of the maximum covered depth. So that means grip length should be greater than one third of maximum covered depth. How much is the covered depth maximum? It is 24 meter. So 1 by 3 24. So that means greater than 8. So grip length should be greater than 8 meter. Okay. So this is it. So let me proceed to the next one. So next question is, determine the required thickness of concrete seal of an open well. Okay, so we have been asked to determine the required thickness of a concrete seal of an open well. Okay, the outside and inside diameter of the well is 8 meter and 6 meter respectively. So outside diameter is 8 meter, inside diameter is how much? It is 6 meter respectively. The depth of the well below the maximum scar level is 10 meter. So depth of the well, so depth of the well below the maximum covered level is 10 meter. Okay, the maximum covered depth is 12 meter below the HFL, and the unit weight of concrete and water is 24 kilonewton per meter cube and 10 kilonewton per meter cube respectively. So this is the unit of concrete and this is the unit weight of water, and the allowable concrete flexural stress is 0.1 times the 28 days compressive strength of concrete. The 28 days compressive strength of concrete is 20 MPa, Only thickness is to be determined, no further checking is required. Okay, so we have been asked to determine only the thickness of the concrete seal. Okay, so thickness. Well, it is a circular pile. Since we have been asked, since the outer and inner diameter is given, it is a circular pile. So thickness is given by 1.18 Ri root over of Q by Fc. Okay, so what is Ri? Ri is the inside radius of the circular well. Ri is the inside radius. What is Q? Q is the unit bearing pressure at the base of the well. Let me write it down over here. Ri is the inside radius of circular well. Q is what? Q is the unit bearing pressure at the base of the wall. Base of the wall. And another one is Fc. Fc is the allowable concrete flexural stress. It is allowable concrete flexural stress, which is around 0.1 times Fc dash. That is the 28 days compressive strength of concrete. Okay. So now let me find out the thickness of the concrete seal. So Q, that the so Q, which is the bearing pressure at the base of the well, Q is how much? So what is the total depth of the well? Okay, let me see. What is the total height of the well? Actually, the total depth. It is the depth of well below the maximum scour level is 10 meter, and also the maximum scour depth is 12 meter below HFL. Okay, so that means suppose this is HFL. So from HFL to scour depth, suppose this is the scour depth SD, up to that the maximum scour depth is 12 meter below HFL. So maximum scour depth, it is 12 meter. Okay, and another thing is there, the depth of well below the maximum scour level is 10 meter. So maximum scour level is this, below this is 10 meter. So total height of the well is how much? It is total depth of the well is 10 plus 12, that is 22 meter. Okay, so Q, it is the bearing pressure at the base of the well. It is how much? We need to consider buoyancy also. See, the weight of this concrete pipe concrete well is acting downwards, but buoyancy force will move upwards. Okay, buoyancy force will counteract that. So Q is how much? So buoyancy force H into omega is H into gamma W, that is unit weight of water into the height of the wall, height of the well, minus, if we don't know the thickness, then T into 24. T is the thickness and 24 is the unit weight of concrete. Okay. So H is how much? H is 22 and gamma W is how much? It is 10 minus 24 T. Okay. Now let me use this equation. 1.18 into Ri. Ri is what? It is the inside radius. Inside diameter is 6 meter. Radius is 6 by 3, that is 3 meter. 6 by 2, so 3 meter. So we have the values of all the parameters over here. We know Ri, we know Q. This one is Q. And how much is Fc? Fc is 0.1 Fc. So Fc dash is 0.1 Fc dash. Okay. And it is also mentioned in the question that the 28 days compressive strength of concrete is 20 MPa. Okay, so fc is equal to 0. Fc dash is equal to 0. Fc, so that means it is 0.1 into 20 MPa, means 20 into 10 to the power 3 kPa. So it comes out to be 2000 kilonewton per meter square. So now we have the values of all the parameters. So thickness is 1.18 Ri root over of Q by Fc. So T is equal to 1.18 into Ri. That is the inside radius. It is how much? It is 6 by 2. That is 3 into root over of Q by Fc. Q is how much? It is 220 minus 24T. And what is Fc? Fc is 2000. We need to solve this to find out the value of T. Okay, so let me just solve. So we can proceed it like this. In this way, you can solve this, the previous equation, and after that you will get a quadratic equation. So t square plus 0.15 t minus 1.38 equal to 0. If you solve this, you will be using Sridhar Acharya's formula. You get the value of t to be around 1.1 meter. So this is the thickness of the concrete seal. Okay. Please go through this problem for a couple of minutes. This is a very important problem. Please go through this problem for a couple of minutes and let me know if you have any doubt regarding this particular question. Okay. Please go through this problem once. I will resume this session after a couple of minutes. I hope you have gone through this problem. Please let me know if you have any doubt in this particular question, or else I'll move to the next one. Okay, so I will give you a couple of minutes more to go through this problem. After that, I will move on to the next question because this is a very important problem, very complicated one. So please go through this problem once again. I am giving you 5 more minutes. After that, I will proceed to the next one. Okay, so I hope you have all understood this problem. So now let me proceed to the final question. So now let me proceed to the final question. So what is the final question? So determine the safe compressive load carrying capacity of an open well. Okay, so here we have been asked to determine the safe compressive load carrying capacity of an open well. The outside and inside diameter of the well is 8 meter and 6 meter respectively. So outside diameter is 8 meter and inside diameter is 6 meter respectively. The depth of well below the maximum scoured level is 10 meter. Okay, suppose this is HFL, and that is the flood level, high flood level, and below that, suppose here it is the scoured level, maximum scoured level. Okay, and the maximum scoured level is 12 meter below HFL. Okay, suppose, and this the distance is 12 meter. Okay, and the bottom of the well is placed in a stiff clay layer with ambient cohesion of 100 kPa. So Cu is how much? It is 100 kPa. And the average ambient cohesion of the soil along the length of wall below the maximum scoured level is 25 kPa. So Cu is at this base, and it's 100 kPa. The Cu is equal to 100 kPa. Uh, the bottom of well is placed in a stiff clay layer with ambient cohesion of 100 kPa. Okay, and the average ambient cohesion of the soil along the length of wall below the maximum scoured level, that means along this length, Cu is around 25 kPa, average ambient cohesion. Okay, the saturated unit weight of soil is 20 kilonewton per meter cube, and water is 10 kilonewton per meter cube. Okay, so gamma soil is equal to how much? 20 kilonewton per meter cube. That is gamma sat. It is 20 kilonewton per meter cube, and gamma W is 10 kilonewton per meter cube. Okay, and what else is there? The factor of safety is 2.5. The factor of safety is 2.5. Okay, so and the adhesion factor is 0.21 plus 0.25 Pa by Cu, less than 1, where P is the atmospheric pressure, is equal to 100 kPa. Okay, so we have been asked to determine the safe compressive load. Okay, so now let me just solve the problem. Okay, so Qu, that is the ultimate compressive load carrying capacity of the open well. So Qu, that is the ultimate load carrying capacity, compressive load carrying capacity, is equal to Qp net plus Qf. Okay, this Qp net is equal to AB, that is the area of the base of the pile. Wait a minute, please. Please let me know if you can see my screen or not. Let me share this document once. Okay, so so QU, that is the ultimate compressive load carrying capacity of the well, is equal to QP net plus QF. Okay, so QP net is equal to AB, that is the cross-sectional area of the base of the well, is CU, and NC, which is the CU underlying cohesion, and NC is the bearing capacity factor. Okay, so it is equal to AB, how much? It is pi by 4 into d squared, that is the diameter of the pile. What is the diameter of the pile? The outer diameter, it is 8 meter. Okay, so 8 meter, pi by 4 into 8 meter, 8 square, into CU. How much is the CU? At the base of the pile, it is 100 kPa. It is 100 kPa at the base of the pile. So 100. In NC is how much? NC is 9. Okay. So now if you calculate this, you will get the value of QP net, which comes out to be 45.2 into 10 to the power 3 kilonewton. Okay. Now QF. QF is equal to alpha CU average into pi into d into L. Okay. Now alpha. We need to calculate the value of alpha. See, here is the equation given in the question, which is 0.21 plus 0.25 Pa by Cu. So 0.21 plus 0.25 Pa by Cu. Okay. So 0.21 plus 0.25 into Pa is how much? Atmospheric pressure is 100 kPa, and Cu, that is the cohesion along the length, along this length, that is below the scour level. Cohesion of soil below the scour level along this length. So it is 25 kPa. So Cu is 25. Now if you solve this, you will get the value of alpha to be 1. Okay. Actually, since and this equation should be less than equal to 1, and okay, so we can write it like 1. Okay, so this alpha is 1. Now QF. So what is QF? QF is equal to alpha into Cu average along the length, along that length below the scour level, into pi into d into L, pi into d into L, and the depth of the well below the maximum scour level is 10 meter. Okay, so 10 meters. So that is the value of L. So alpha is how much? Alpha is 1 into Cu average, that is the cohesion along this depth, which is 25, into pi into outer diameter is how much? Outer diameter is 8 meter, and length below the scour level is 10 meter. If we calculate this, you will get the value of QF, which comes out to be around 6.3 into 10 to the power 3 kilonewton. Okay, now we need to find out the value of Q. We need to just add up both the terms, QF plus this one, QU. Okay, so QU, so no, QP net, this QP net, and this one, QF. We need to add both the terms. So how much is QP net? QP net is 45.2 10 to the power 3. 45.2 10 to the power 3 plus how much is QF? It is 6.3 into 10 to the power 3. Now, if we add both the terms, we will get the ultimate compressive load carrying capacity of the well. It is 51.5 into 10 to the power 3 kilonewton. We can also write it like this, 51.5 meganewton. Now, if we need to find out the safe compressive load carrying capacity, okay, so that is which is equal to QU, that is the ultimate compressive load carrying capacity, divided by factor of safety. And the factor of safety, which is given in the question, factor of safety, we have been asked to consider the factor of safety of how much? 2.5. Okay, so we need to divide this QU, that is 51.5 by 2.5. So 51.5 divided 2.5, and it comes out to be around 20.6 meganewton. So this is the answer. So please let me know if you have any problem in this particular question. Please go through this problem once. Please let me know if you have any doubts. So I hope you have all understood this problem. And if you face any problem later on, you can always mail me. You can also post your doubts in the forum. And recordings of all the previous session and also the recording of today's session will also be made available on YouTube. You can find the links in the NPTEL on the NPTEL website, and you can also email me. My email address is available over there on the YouTube videos. You can also mail me personally. And okay, so that is all for today. See you in the next session. That's all. Goodbye.